Earth's orbit is increasingly crowded with fragments of old satellites, rocket parts, and broken machinery. These pieces, some no larger than a bolt, hurtle at tremendous speeds, creating a dangerous barrier for new missions. The problem is visible, from scratched solar panels to drifting particles that were once parts of groundbreaking space missions. The question is, how do we tackle this threat?
Space exploration began with the excitement of discovery, sending rockets into the unknown. However, each launch left behind remnants, pieces of rockets and outdated technology, slowly turning into potential hazards. The early space age laid the foundations for what we now call space junk. A risk not foreseen at the time, but a growing threat that affects us today.
Today, space debris fills the orbital paths surrounding our planet. Thousands of objects are tracked continuously, and the number only grows. Engineers use advanced tracking systems to monitor every piece larger than 10 centimeters, highlighting just how congested these orbits have become. Every new mission must navigate this growing sea of floating hazards.
Space junk is not only a technical problem. It's an environmental one too. Satellites must dodge fragments to avoid damage. The risks are real. Small objects can tear solar panels, while larger pieces could destroy entire satellites. Even the International Space Station isn't safe from these threats. Our increasing reliance on space makes tackling this issue all the more urgent.
In the early days of space exploration, satellites were launched without concern for what would happen once their missions ended. Each launch left behind remnants, discarded parts, dead satellites, and other forgotten technology that still drifts above us. The consequences of these actions now linger, haunting our atmosphere with fragments of human progress.
Space debris comes in many forms. From entire satellites left derelict, to tiny fragments resulting from disintegration or collisions. These pieces range from large trackable objects to smaller, almost invisible fragments, all of which pose a serious threat. The varied debris together creates a chaotic and dangerous environment in orbit.
The collision of satellites is one of the main reasons space debris continues to multiply. One crash can send thousands of fragments in every direction, creating a ripple effect. Each piece becomes a new hazard, capable of causing further collisions, adding to an endless cycle of fragmentation and danger.
As more satellites are launched, the chances of collision continue to rise. Operators now have to make complex calculations to ensure their satellites can safely navigate the crowded environment. A single misstep can put an entire mission at risk. The traffic in space has become almost as chaotic as the highways on Earth, only here, the stakes are far higher.
In the history of space missions, several near misses with space debris have brought us to the edge of catastrophe. In 2009, for example, a defunct Russian satellite collided with an American communications satellite, creating thousands of new fragments. This incident was a wake-up call, emphasizing how small trajectory shifts can cause major consequences. Today, engineers and control centers are more vigilant than ever, making constant course corrections to keep valuable missions safe from these historical threats.
Astronauts aboard the International Space Station have faced multiple threats from space debris since its inception. In 1983, a fragment from an exploded booster almost hit the shuttle Challenger. Such incidents have since led to heightened safety protocols. Every scratch on the ISS is a reminder of these close calls, and the crew maintains regular communication with mission control, ensuring their safety against this ever-present danger that was overlooked in the early days of space exploration.
Even small pieces of space debris can cause significant damage, as seen in 1996 when a fragment from a French rocket collided with a Ceres satellite, tearing off a part of its stabilizing boom. This historical example showed just how destructive even tiny fragments can be. Now, satellites must withstand these impacts, often bending under the force. which results in expensive damage and the creation of yet more debris in a dangerous cycle.
Space debris has posed a risk to satellites and Earth-based services for decades. The collision of Iridium-33 and Cosmos 2251 in 2009 highlighted how fragile our satellite network is. Such collisions have a direct impact on services like GPS and communications, and ground teams must react rapidly to protect these assets. Maneuvers are now routine to avoid such incidents, underscoring the lessons learned from past collisions and the urgency to maintain our vital connections.
Tracking space debris in real time requires sophisticated technologies. Global space agencies have set up state-of-the-art monitoring centers with engineers working around the clock. Advanced radar and computer systems ensure every fragment in Earth's orbit is tracked, helping prevent dangerous collisions. These tools provide a live feed, pinpointing even the smallest object speeding around our planet.
Observatories around the world are playing an essential role in monitoring space junk. Technicians and astronomers use radar systems and telescopes to keep an eye on the debris, adjusting their instruments for precise tracking. Through these detailed observations, they provide critical data for space agencies to maintain safe orbits. Every night, dedicated teams watch as thousands of objects move across the sky.
Tracking space junk isn't the responsibility of a single nation. It requires international cooperation, with representatives from spacefaring nations gathering regularly to share data and develop strategies. These joint efforts, through meetings, video conferences, and collaborative missions, are key to maintaining space safety. It's a challenge that transcends borders, uniting nations in a common cause.
The sheer volume of space debris has made tracking a daunting challenge. Engineers monitor vast amounts of data, constantly dealing with alerts for potential collisions. Every day, new fragments are added, further congesting the already busy orbit. This relentless increase pushes current tracking systems to their limits, requiring constant vigilance and upgrades to keep up with the growing threat.
Space debris poses a significant challenge not only for space agencies, but also for astronomers. The clutter in Earth's orbit obstructs clear views of the stars, making it harder for astronomers to observe celestial events. For amateur astronomers, the increasing number of fragments passing through the field of view can disrupt stargazing sessions, reducing opportunities to witness and document key astronomical phenomena.
Active measures to manage space debris are crucial for preserving the night sky. Deploying technologies like deorbit sails can reduce the number of objects that interfere with astronomical observations. By mitigating the amount of space junk, we help protect the pristine view of space that astronomers, both professional and amateur, rely on for their work and passion.
International cooperation is essential to address the challenges that space debris creates for astronomical observation. By coordinating efforts, countries can work towards minimizing light pollution and interference caused by orbiting junk. This collective action is key to maintaining space as a shared resource for science, discovery, and inspiration.
Future technologies hold the promise of minimizing the impact of space debris on astronomy. Projects like orbital lasers aim to remove small particles that obstruct telescopes. As we develop and implement these technologies, we can ensure a clearer, unobstructed view of the cosmos, allowing both seasoned astronomers and casual stargazers to explore the wonders of the universe. Though the challenge is significant, humanity has faced greater obstacles and overcome them. By working together, embracing new technologies, and fostering international cooperation, we can protect Earth's orbit. A clean space is not just a dream, it is a future that we must all strive for, ensuring our planet remains open to exploration and opportunity.